Hello everyone, we're going to do some polyatomic practice today. So if you're viewing this video as a makeup lesson, then pay attention, work through the problems, and then you'll have an exit slip at the end. If you're viewing this video as a little bit more practice, alright, watch, learn, ask questions. You could always send me questions through Google Classroom or Remind Text. But here we go. So don't forget that polyatomic, poly meaning many, so many atoms that act like one thing. All right, and I gave you last week this ion sheet, all right, over common polyatomic ions. All right, and yes, it is on Google Classroom. But as you can see, these are the ones that we're going to focus on just to make it a little bit more simple. All right, these are their formulas. We have their charge right here. So you don't have to go searching on the internet. You already have it. Okay, now these formulas are the polyatomics themselves. And we talked about how we use parentheses to protect the polyatomics. All right, so like if we have hydroxide, OH, we'd put parentheses around it before we put any number right here. So this number goes on the outside. It doesn't go on the inside of the parentheses. So yes, you have to have parentheses there. All right. If you said OH3 like that, well then guess what? You are wrong. So don't do that. Put parentheses to protect the polyatomic. All right. P words. Now, it's C2H3. Use our chart to figure out acetate. Acetate is a -1. So look at our little chart. Phosphate is right here. It's PO4. Phosphate. Phosphate is a -3. Paper, and remember it's on Google Classroom for you to, figure it out. So we got CN. It's a carbon and nitrogen together, and it's a -1. So cyanide poisoning comes from a carbon and nitrogen that's attached in a special way. Go back all the way. Where is NO3? Ah, look, it's nitrate. So that's all we got. We're still going to be looking at the oxidation numbers for the rest of the ions. All right, so we use this right here. And this will help us focus and figure out those ion charges. All right, so let's go ahead and look at a couple of acetate. O2. Calcium is. Calcium is right here. It is a +2 charge. And then charge. Well, aluminum is right here. It is a +3 charge. And let's go ahead. So we got a polyatomic examples. All right, so our first example is calcium acetate. Okay, we know calcium. What's the symbol for acetate? Okay, we're going to go ahead and put parentheses right here before we find out the charge, just so we remember to protect it. All right, let's look up. So I'm going to go ahead and put a +2 there. All right, and then we begin crisscross. Crisscross is the same as it was for the regular ions. All right, this 2 is going to go right there. The charge of the second tells me how many I need of the first. And so what I end up with is Ca1, but we remember we don't write ones. All right, parentheses, C2H3O2, parentheses, and then this 2 goes right there on the outside. Now look at this formula. All right, note the polyatomic is still by itself in the parentheses. The acetate was used on the homework for last week, and I could tell if you went online to look at it, all right, to search for the answer, because you didn't have this format. All right, acetate wasn't by itself, and you just wrote out what the web told you, and it was wrong. It was not in the right format. So remember, don't look at the internet. Use your brain, because the internet's going to give you the wrong answer, or at least the wrong format. And we're learning this format for a reason. It helps us with later parts of chemistry, and that's the correct way of listing it. All right, it's not a shorthand way. So we got calcium acetate. Let's take a look at phosphate. Aluminum +3 charge. Another example. Aluminum phosphate. Well, our symbol for aluminum is Al. And what is it? All right, so we're going to write PO4. I'm going to put parentheses to protect the phosphate. Okay, now let's look at our charge and a -3 charge. So I got +3. And we got -3. Okay, now, if you're looking at these numbers, you realize that we already talked about this situation before. If they're the same number, that they're going to cancel out through simplification. But let's go ahead and show you the long way so I can show you what I mean. So we got this 3, it's going to go right there. This 3 goes right there. And so I end up with AL3 PO4 3. And like we've talked about many times before, we know that this is not the right answer because it could be simplified. Alright? Looking at these two numbers, they're both divisible by 1 and 3. So if I divide 3 divided by 3, I get 1. And the other one, 3 divided by 3, I get 1. So the correct answer is ALPO4. And that's it. No 3s or no 3 subscripts are in the equation. Now you're probably asking yourself, hey Ruggles, do I need these parentheses right here if I have no number? Alright, so technically the parentheses are there to protect the polyatomics when you put subscripts on the outside. But if there's no subscripts, alright, if there's no subscripts, then technically you don't need these. But if you want to leave them there, go right ahead. I'd rather you have them and not need them than need them and not have them. You know what I'm saying? And also, just as a reminder for some things I saw on the homework, note, there's no spaces in between right here. No plus signs, no spaces. It's written as one thing. This is all like one word almost. Okay, so keep that in mind as well. I don't have to worry about... Okay, let's try another one. Oh, look. We have Roman numerals, right? We talked about that. That means it's that charge for that transition metal. And I was only going to give you answers. You never had to name one with the Roman numerals. I'm only going to give them to you in the crisscross. But let's go ahead and see what it works out to be. So I got Fe, which is iron. And we automatically know that this right here is the charge, so that's a +3. But now we got to look up cyanide and whatever it is. So we got Cn. And I'm going to go ahead and put parentheses around it. It's a -1. Okay, let's crisscross like normal. Charge of the first tells me how many I need a second. Charge of the second tells me how many I need as the first. Notice when they drop down, they lose their plus or minus. And we get Fe1, but we don't write ones. Cn3. Yep, the parentheses were there to protect the polyatomics. We don't have ones, we don't have charges, and we don't have spaces or pluses in between this. This is the correct chemical formula. Alright, so when I ask for the formula, I'm looking for something like this. I'm not asking for the name, because I already gave that to you, but I'm asking for the formula. Formula has the letters and numbers and stuff, right? Like H2O or CO2. IDE. And right, but how do we name polyatomics? Alright, now naming polyatomics is not bad. The first one, it keeps its name, whatever it is on the periodic table. And naming polyatomics is easier than naming regular ionic formulas because you don't have to worry about that IDE ending. The second one, you just look it up and write it down. Okay, so let's go ahead and work this one out. So this name right here, this is magnesium. Okay, now we gotta look up what NO3 is. You just simply write down nitrate, part of my handwriting. But that's it for naming. That's all we do for names. So if you got this, so you go back and review this video, you could look up, make sure you're doing things right. You should be ready for this exit slip. So this is only if you were absent or you missed today's class. Then you need to do this, okay? To get credit for this exit slip, you got to solve it, okay? And wait, pay attention to this. send the answer to me on a private message on Google Classroom on this assignment or remind text. That's the only way you're going to get credit for this participation for this lesson, okay? If you don't send it to me and you just say, well, hey, Ruggles, I watched the video, well, then obviously, no, you didn't. You did not participate because you did not complete this exit slip, and I will give you no participation points for it. All right? So what you're going to do is look up this right here, okay? Not look it up on the internet, but go ahead and crisscross it and find the right formula. Okay, so you're going to do this on a message to me on Google Classroom, on the assignment. You know how you could put like little comments, put it in your submission, or send it to me on remind text and you will get credit. All right, so that's that. Feel free to contact me if you got any more questions.